Hey everybody, welcome back to HPC Tech Shorts, the engineering water cooler here in AWS. Now this week there's been a new version of ParallelCluster, ParallelCluster 3.2, which has just been released, and there's a bunch of new features. And we're gonna split this discussion over two tech shorts to discuss them all because there's quite a lot of stuff to talk about. The first bundle of features are to do with file systems. We've added more options for file systems in the Fsx family, and we've also added the capability of building your cluster with a whole lot of file systems attached to it. So rather than just the old days of just one EFS or one Fsx cluster, you can actually now have a whole plethora of file systems. So we're going to talk about that in the first episode today. In the next episode, which we will release either today or early next week, we're gonna talk about memory-aware scheduling in Slurm and a couple of other minor changes to the way that we do the scheduling in Slurm. Memory-aware scheduling is really important if you have memory-intensive jobs. It's no fun having your jobs getting deep sixed because because you ran out of memory, because you overestimated how much memory was available, or you had co-located jobs on the same host where they were competing for the same memory resource, and your jobs were losing out. So memory-aware scheduling is now possible in ParallelCluster 3.2, and we're going to talk about that in the next tech short. But today we're joined, in each of these episodes, we're going to be joined by the two most important people in this universe for ParallelCluster. At least this is how I think of them. The first one is Olly Perks, who's based here in London and is our senior developer advocate for ParallelCluster. And the other is Austin Cherian, who's actually in flight at the moment, moving from Singapore to Seattle. And he's our senior product manager for ParallelCluster and HPC. So both of these guys have got years of experience and a whole lot of insight into how things should be working and hopefully the way they are working. So I hope you enjoy the discussion.
So let's frame this. So there's a couple of big things. We've got support for some additional file systems like ZFS, Netapp ONTAP, and so forth. But we've also got this ability to have multiple file systems now, like actually quite tons, isn't it? I think it's like 20 of each type. I mean, it's if you've got a cluster, trust me, folks, if you've got a cluster and it's got 60 file systems attached to it, you've actually got bigger problems than, well, actually, you've got a data management problem, period. Anyway.
Right, so let's talk about where we are at the moment. So prior to 3.2's development that we're discussing today, we could basically mount a single file system of each file system type. So that meant you could tell ParallelCluster, hey, I've got a Lustre file system here that I've created. Can you mount it for me? Can you put it on the head node? Can you make it accessible on the compute nodes? And hey, your data's there.
You could also ask it to create one for you, right?
Right. And that's a bit of a subtlety and a special case. So for Fsx for Lustre, there's support for Scratch file systems. So these are designed to be temporary data stores. So we've set up a capability that's been there since we introduced support for Fsx for Lustre to allow ParallelCluster to manage your Lustre file system. So when it creates the cluster, it also creates the Lustre file system. And when you delete your cluster, it also deletes your file system. So this is a very special use case. Most people don't think of their data as transient like this. So this is quite a special case. So what we're actually talking about here is increasing the capacity of mounting external file systems. So these are file systems that you've created either through the console or through the CLI that have your data already in before you create your cluster and will persist after you delete your cluster.
So Olly, this could just be a case where somebody was using OpenZFS for user data and they're keeping that in, say, I don't know, some particular area. It's not Scratch data. It's not high performance file system. It's just user data.
Right. And we do this quite often. We set up mounts that have our software installs. So every time you've got big packages to install, you install it on a shared file system and make that accessible.
Right. So one of the key things that is interesting about this feature is absolutely it allows you to bring multiple file systems to a cluster that you're going to create. And one of the main aspect over here is that prior to this release, a typical user had to consolidate their data strategy for parallel cluster, for creating cluster. And that would entail sort of bringing all of the data together into one share and then mounting that one single share onto the cluster. But now they have the flexibility of actually bringing in all of the file systems that they are sort of maintaining and created to the cluster, and then not have the hassle of centralizing all of the data before they create
That
the
makes
cluster.
sense. These could be
That's a
like
major
seasonal,
advantage.
these could be like seasonal data sets they're lifting out of S3 into
Exactly.
FSX cluster, which you've got,
Exactly.
Okay, that makes a whole lot of sense. So now, what about FSX? So there's FSX for OpenZFS. We all know about that one because it's kind of ZFS is really popular. What's Netapp ONTAP?
So Netapp ONTAP is the Netapp's network operating system. Essentially, it's mainly used in the enterprise space for a multitude of different types of use cases. One of the reasons why we're actually allowing users to bring this to ParallelCluster is so that they have probably shared data on Netapp ONTAP, which have engineering use cases that they might also want to use in their HPC scenarios.
All right, so how does it manifest itself? We've got a config file here to show off how this works. Austin, do you want to talk us through this?
Sure. Yeah. So the existing setup, which is in white over here, is something that you already have in ParallelCluster, and this is a typical example of the YAML configuration part for the storage, for the shared storage that you can include as part of the ParallelCluster configuration file. The part in yellow is the edition that we have for the two file systems, which is basically the Netapp ONTAP and the OpenZFS file systems. And as you can see, there's a bit of a difference between how you would use it for Lustre and for Netapp ONTAP and OpenZFS. In Netapp ONTAP and OpenZFS, you actually provide volume IDs. But for FSX Lustre, as you know, we've been providing file system IDs, and the same is the case with EFS as well.
Right.
And now we're providing a mechanism to actually provide 20 FSX file systems and 20 EFS file systems in the same configuration file. So you can go all the way up to a mix of all of these different file systems and have 20 of FSX file systems, and essentially
and when you say 20 FSX, do you mean 20 FSX for Lustre, 20 FSX for OpenZFS, 20 FSX for Netapp ONTAP?
So there's a subtlety over there. So it's a 20 FSX of overall any of a mix of these file systems.
So collectively, all of the FSX file systems, a maximum of 20. Got it?
Exactly.
Okay.
Exactly.
That makes sense.
Right.
I just want to make sure that we got that. So correction, folks. If you've got 20 EFS file systems and 20 FSX file systems, you still have a data management problem. So if you're going to breach these limits and complain to us, we should talk about your data management practices.
Absolutely. We are making it simple for you, but you definitely have something else going on that you need to fix.
Right. So I've gone into FSX and I've just created a whole bunch of the different types of FSX file systems that we could then mount into ParallelCluster in this configuration file. So you'll see here that I've got two FSX for Lustre file systems, one based on persistent storage, one based on Scratch. I've got a Netapp ONTAP file system and an OpenZFS. So when we're dealing with Lustre, we mount based on the file system ID. So that's very obvious. That's up here. And we can just copy that and take that into the config file. But as we said, when we're working with Netapp ONTAP and OpenZFS, we need to specify the volume ID. So the easiest way to do that is to go into our file system. In the case of OpenZFS, we have the root volume ID, which we might want to use if we've only got one volume, and that's presented up front. But if we have a more complex file system, we can actually go to the volumes tab here, and you'll see that I've actually got two volumes available on this file system, and both of them are presenting their volume ID that we can take and integrate into the config file for our cluster.
Okay, so I hope you got a lot out of the conversation today. We're coming back in the next episode to talk about memory-aware scheduling in Slurm and a few other little tidbits associated with Slurm scheduling behavior inside ParallelCluster 3.2. So come back for that. If you like what you're seeing and you're getting a lot out of this, please consider subscribing to the channel and definitely click like on this video. If you subscribe to the channel, you'll be able to keep up with everything else that we're doing. And if there's something we're not diving into that you'd like to see us dedicate some effort to and to talk about, please come and find us on Twitter. Our DMs are open. Until then, thanks for watching.